You take better photos with your phone than professional photographers took 10 years ago with $5,000 cameras. This shouldn't be possible. Your phone's camera sensor is the size of a fingernail. A professional camera sensor is the size of your palm. Bigger sensors capture more light. More light means better photos. That's physics. But you consistently get better night shots, sharper portraits, clearer action photos than dedicated cameras costing 10 times more. The physics didn't change. Photography did. (2015) iPhone 6s sensor measures 4.8 by 3.6 millimeters. A professional camera sensor is 36 by 24 millimeters. 50 times more surface area, 50 times more light. The gap was impossible to close with hardware. Phones need to be thin. Optics require distance. There's no space. You can't make sensors bigger without making phones thicker. Canon and Nikon spent a century refining optics. Their lenses cost thousands. Phone makers had millimeters of depth and dollars of budget. Physics said phones would always lose. Then someone asked, what if we don't take one photo? What if we take 9? The solution was computational photography. Stop thinking like a camera. Start thinking like a computer. Here's what happens when you press the shutter on a modern phone. The moment you tap, the phone has already captured 4 frames. Before you even touch the screen, it's constantly buffering images, analyzing the scene, preparing when you tap, it captures 4 more frames instantly. Then it shoots one final frame with different exposure. 9 photos total, captured in the time it takes to blink, each exposed slightly differently. Each capturing different information. Then the magic happens. An AI chip analyzes all 9 images. It takes the sharpest details from each, combines the best exposed areas, removes noise by comparing frames, enhances color by analyzing the scene. The photo you see isn't one photo. It's a computational synthesis of 9 photos, processed through algorithms trained on millions of images. You pressed one button. The phone did 9 captures and 1 billion calculations. This changed everything. Manufacturing, this requires impossible precision. Each camera module has 6 glass elements. Each must align within 5 micrometers. 1/20th the width of human hair. 6 micrometers off? Module fails. Samsung makes 500 million camera modules yearly. 3 billion lens elements. Each ground-coated, assembled by $10 million machines. 15% fail quality test. The tolerances are that tight. The sensor uses quad-Bayer arrays. 4 pixels act as one. Bright light, they separate for detail. Low light, they combine for sensitivity. This requires semiconductor fabrication at chip-level precision. Optical image stabilization floats the entire sensor on magnetic fields. Adjust 5,000 times per second. 6 magnets, 4 springs, gyroscopic sensors, packed into module thinner than 3 credit cards. Inside that camera bump, 6 lens elements, each shaped to correct specific aberrations. Stacked, 0.3 millimeters apart. Total height, 5 millimeters. The sensor has 12 million photosites, each one 1.4 micrometers across. Human red blood cells are 7 micrometers. These photosites are smaller than blood cells, capturing individual photons. The breakthrough is the image signal processor. Apple's ISP does 4 trillion operations per photo, not per second, per photo. It analyzes 12 million pixels across 9 frames, applies machine learning for scene detection, outputs final image in 0.3 seconds. Google takes 15 frames, uses ML trained on professional photography. Samsung prioritizes color over noise reduction. Same challenge, different computational solutions. This is why dedicated camera sales dropped 87% in 10 years. It's not because phone cameras have better hardware, they don't. A full-frame camera still gathers 50 times more light, professional lenses are still sharper. But computational photography compounds. Every year the algorithms improve. The machine learning models train on billions more photos. The ISP gets faster. The phone learns what good photos look like, then creates them automatically. Here's why this matters to you. When you take a photo of your kid at a birthday party, the phone recognizes it's a person in low light. It adjusts skin tones, sharpens eyes, blurs background. When you photograph food, it knows to enhance warm colors and increase saturation. When you shoot landscapes, it extends dynamic range and sharpens distant details. You're not a better photographer than professionals. You have a better computer that knows photography. Every photo you've taken in the last 3 years used computational algorithms that didn't exist 5 years ago. Here's what actually changed. Photography was about capturing light. Now it's about computing images. The sensor barely matters anymore compared to the software processing. Apple and Google spend more on computational photography engineers than optical engineers. Think about what this means. A photo used to be a record of light hitting a surface at one moment. Now it's a computational creation from multiple moments, optimized by AI, adjusted based on what the algorithm thinks makes a good photo. You're not taking pictures, you're directing a computer to create images based on the scene you point at. The camera industry spent 150 years perfecting optics. Phone makers beat them in 10 years by changing what a camera is. Turns out the bottleneck wasn't glass quality. It was computation. Next time you take a photo, remember, you pressed a button once. The phone captured 9 frames, ran a trillion calculations, and created something that never existed in reality. That's not a photo. That's computed art that looks like reality. Tomorrow, the glass protecting that camera can survive a 6-foot drop onto concrete. How Gorilla Glass engineering creates transparent armor.